Welcome back, guys. Mr. Bennett here. We're going to look at the second example, the second method for doing first principles, and that's one where you have a surd. And what we do here is we use the idea of the conjugate. Okay, so the conjugate is pretty simple, and I'll just do a little bit of theory over here first up. So if we're thinking about a conjugate, if I had something like root A plus root B, and if you times that by root A, take root B, and you fall that out, what are you going to get? Well, A times root A, and you're going to get root A times by root B, and you're going to get minus root A times by root B, and then you're going to get minus root B times by root B. So root A times root A is A. These two things cross out, and then that root B times root B is going to be B. So we're going to use that concept over there for the conjugate to actually do our derivative. Alright, so let's get into doing this one here. So f dashed of x is equal to the limit as h goes to 0 of f of x plus h, take f of x all over h. So that's our definition for the first principles. So that's equal to the limit as h goes to 0. Now, all we do with that f of x plus h is we put an x plus h in there. So let's do it. So that will be 5 x plus h funny looking h plus 3, I think you can sort of see what I'm doing, take away the square root of 5x plus 3, and that's all over h. Now we're going to times by the conjugate. Now the conjugate's pretty easy to think about what it is, and it's simply going to be the same thing here, but you're going to change the sign. Okay, so that's going to be the square root of 5x plus h plus 3, and instead of being take, it's now going to become plus 5x plus 3. Now you can't just times by the conjugate and change the equation. So what we do is we times by that, and we make sure it's like the same thing on the bottom line. And that way, when you cancel that out, it's like timesing by 1. Alright, so you're not changing the equation, we're just rearranging it into a different form. Okay, so if you think about this now, you've got this whole thing here times this whole thing here. It's exactly like what we had up there. So the next line is, and pretty simple, we're just going to write the top line out now. The secret here is don't do anything to the bottom line. The bottom line sorts itself out in a second. Alright, so the top line, we're going to get rid of the surds. On the top line we're going to have 5x plus h plus 3, and then we're going to have take, and don't forget your bracket, 5x plus 3. On the bottom line, we're going to have h. We're going to have what we have over there, this stuff over here. Alright, so that's going to be 5x plus h. It doesn't look nice, but don't simplify it. The bottom line never gets simplified. It sorts itself out in a second. Plus the square root of 5x plus 3. Okay, now we're going to expand the top line now, because it's now going to treat it like basically the surds, the polynomials example. So we have to expand the bracket, so that's going to give me 5x plus 5h plus 3. Take the negative through, and we take 5x, take 3. that's all going to be over. It's a bit annoying having to write this out, but you have to. That's the square root of 5x plus h plus 3 plus 5x plus 3. Right? Now we can cancel out like terms, and again it's a bit like the other one. We expect every term that doesn't have a h in it to cancel out. Now rather than rewriting this again, I'm going to cancel that h there with that h there, and that means that I can take the limit. So f dashed of x, as I take the limit of h goes to 0, on the top line, what are we going to have left? We're going to have 5. Okay? The bottom line, we're going to make that equal to the square root of 5x. Now x plus h, the h is 0, so it's going to be 5x plus 3, and then plus 5x plus 3. Now you go, oh, that's nice and neat how that works out. So we can now write that as 5 all over 2 lots of 5x plus 3. So therefore f dashed of x is equal to that. Now, like the other ones, if we want to, what we can do is we can put the value of x in there and find the slope of the tangent at any point. Alright, so that's one example of the method 2, which is the third method. Alright, so I'll do another example for you in the next video. Alright, bye for now.